Hi everyone. Let's continue from where we left. So last time we talked about concurrency, parallelism. We talked about how Go routines work, and we also did a few programs on how we can write these Go routines. Today we will continue that forward. We will talk about how do we work with the weight groups in sync. So let's get started. I am at my code editor, and this is where we left yesterday. Let's create another one. Another folder. Let's call it weight group. All of these will be separate projects itself. So I'll call it a main.go. So we are going to talk about sync dot weight group. So this is part of the sync package. And what weight group does is basically it waits for a collection of Go routines to be finished. So this is how we can make sure that, okay, these we have like n number of Go routines and all n of them have been completed before we exit our main function. For example, if I write a Go routine where I say, let me say random, I'll print some random string and I'll do this. Now, when I run this, nothing gets printed. Why? Because this Go routine was running parallelly, concurrently, but this main function exited because this main function had nothing else. So it completed. And if the main execution completed, the programs get completed, right? So we do not care about Go routines at that case. That is where weight groups come in. What weight groups do is that it will keep track of every Go routine. How do we do that? We do that by the help of, let me first create a weight group. I'll call it WG and it is sync dot weight group. This is how we create weight group. And then I'm saying that weight group can keep track of number of Go routines. How do we do that? I'm creating a Go routine. So for that, I'll do weight group dot add and I'll add one to it. What do I mean by that? I mean that before creating a Go routine, I have added one to the weight group. I'm creating one Go routine. That's why I'm adding one. You can add two here, three here, whatever number, right? Go-routine has been created, so we are adding one here. So this is how we can keep track of, okay, go-routine has been created. But we have not kept track of if go-routine has been completed or not. Next, what we do is we will say, for example, I'll use differ here, and let's say wg dot done. This basically is an acknowledgement that yes, the wait group, the go-routine has been completed. And I'll do one thing. I'll add wg dot wait here. Now I'll explain what happens with all these things. Firstly, let's talk about differ. What differ is, so it's a keyword in Go, which is basically used to call any this function. So differ takes a function, not takes, but differ basically we write it before a function, and it makes sure that this function or this function will be called or this function will be scheduled after the parent function returns but before the parent function exits. What do I mean by that? I mean that, for example, I'm creating any random function ABC and it returns something. For example, it returns an int. It takes this and it returns an int. What I mean that we'll do a few things, right? We'll do something here, we'll do something here, and then we will return whatever thing we are returning, right? So what differ does is if we add something called differ here, and if we add a function call here, whatever function call this is, right? This differ function call will be scheduled before this parent function, this ABC function, this parent function returns. After this parent function returns, which is when it will return ABC. But before it exits, so what happens is this function will be called. For example, we call this function in main. So this function starts getting executed and then it returns and then it exits and then we again are at main. We start executing the rest part of main. That is where defer function comes. Between that defer function comes where as soon as we return A, but before it is exited, as soon as we return the statement, but before it exits and we start executing the main function again, that is where defer function will be executed. So why would we use it? We would use it, for example, for cleaning tasks, for closing files, etc. Like in this case, we have a good case for defer. For example, if this ABC function, we were actually opening a file, right? We were through file handling, we were opening a file. Now we will need to close the file as well. That is where we can use defer function to close the file. So defer can have a lot of like use cases. It's a really interesting concept that Go came up with. I think other new languages have also taken it up from Go. But yes, we will understand it here only. So what we are doing? What happens is, like I said, with add keyword, we can add, let me add a counter here. So the counter starts at 0. By add, we add something to the counter. So now the counter is 1. Now, as soon as this go function runs, okay, as soon as this go routine gets completed, what happens? We will call defer, right? As soon as this gets completed and the go routine is completed, the defer function will be called, this thing will be called, and this basically means we will reduce the counter. So we'll reduce the counter by 1 and it again becomes 0. Now the counter will become 0. And only when the counter is 0, we can move ahead after wait. So wait will wait until and wait will halt the execution of main until we have 0. Until the counter becomes 0. That is how the wait group will keep track of number of go routines. Every time we create a go routine, we will increment the add by 1 or whatever number of go routines we are creating. And then in each go routine, we will add this defer function and we will add done into it. And we'll make sure that we wait, like we will add this wait so that we will wait and nothing ahead will be executed. Like whatever we type here will not be executed until the counter again becomes 0. So now if we run it, I think it should run. We talked about this. I don't think we need this. Let me remove a few things. Counter. Let me remove this. So what we have done is we have added one. Then we are running the go routine. As soon as the go routine is completed, we have called the done part and then we are waiting. Yes, I think this should run now. So now we can see that this gets executed. If I remove this, I remove everything about the wait group and I run it again. Remove this also. Now when I run it, nothing gets printed. But when I bring them up, it will surely get printed. One more thing. Unless we have like the counter becomes 0, wait will not let anything being executed after this. So that is what wait is doing. It is not that wait is making the main function wait. Actually, wait is halting all the like it is halting the execution of the main function until the counter becomes 0. So until the counter becomes 0, this will not be printed. So first this should be printed, only then done will be printed. That is what we see here. Let us take another example. So I'll remove this part. Let us create a function and it does a particular job. So let's call it job. It will take I as int and it will take weight group. We'll look at this later. For now, let's move ahead. What it does is it is going to print some stuff. So it will start the job. Let's say start the job, and then it does a few things, and then it will say job is done. Let me also give it a number. This has to be printf then. Yes. So we are going to do a particular job in this case. Let me remove this. Let me remove weight group for now. First, we will run it without the weight group. Let me create a for loop and we will create 5 such jobs. So from 0 till 5, smaller than 5. And we will say, we will call this job, but we will create a go routine while calling this job, right? And once everything is done, we can say done, or we can say end. Now, what do you think? Will it print the whatever we are trying to print here? Will this work 5 times, or will it simply exit? If you think that this will simply exit, then you are probably right. Let us run this. And it simply exits by printing end. Nothing here will be printed. Why? Because we do not have any wait group, so it is not going to wait. This will parallelly start being executed. But since main function only has this thing here, it will not take much time before main function will exit. And once main function is done, the program exits, and we did not even have time to like concurrently run these Goroutines. So now let's add weight group and see how it will work with weight group. So I'll add this weight group, and every time we add a new go routine, we need to add, or we need to what do you call it? We need to increment the counter. So we'll increment the counter by 1, and as soon as it is completed, we will have to say defer wg dot done, so that the counter is decremented by 1. Now, if you remember, what we did previously was we could simply call wait group inside the anonymous function, right? That is because of the fact that it had closure. So it could, what is closure? Let's not go there, but it could directly access the wait group that we created here. So earlier, what we did was it was like go func, and inside that we were calling wg.turn. See, if I call wg, it is not an issue here. If I call wg here, it is somehow an issue. What happened? Okay, this thing. See, wg and wg shows a red line here, but wg does not show a red line here. Why is it so? Because this is an anonymous function, an anonymous function, due to the fact they have closure, they can access the elements, the variables of the parent function. So that's what this anonymous function is doing. But now that we have created a separate function, we cannot do that, right? So what we have to do here is we'll have to bring the weight group here. So for that, we'll have to pass it by reference. So I'll add %wg here, and it should be a pointer to wg. It should be a wg, which is actually a pointer to sync.wait group. It is a type of sync.wait group, a pointer of sync of wait group. Now it should work fine. Now we can do defer.done, and here I can say wg.wait. Now I think it should work. Let's have a look. So we created this wait group, and now we are going to run it 5 times. We are going to run this job 5 times, and every time we run it, we add one, and every time it is done, we call it done, and we wait for it so that it is completed 5 times. Now it should work fine, I think. If I say go run main.go, we can see that it ran 5 times, 0, 1, 2, 3, 4. So it ran 5 times. And if you look, it is not running like first for the 0th time, then 1, then 2. It is running randomly. Why? Because parallelly things are being executed, and all these things have, like if I run it again, it will follow a different pattern, right? Yes, it did. So first was 3 and then 1. Now it is first 3, then 0. So it can follow different pattern because it depends upon like a lot of variables. The execution happening concurrently depends upon a lot of variables. But I hope you got the idea of the wait group here. That's why we are using wait group. Why do we use wait group? So that we can make sure all the collection of Go routines that we are creating, all of them gets completed before we start executing any other thing. So this is basically how the wait groups work. If we look at the counter part, like the way I added counters, so this will keep on adding 1 and this becomes 0 again, 1 and then 0 again, and then 1 and then 0 again. If I do 2, so every single time 2 will be added. Now if we run this, see, you'll see that it becomes a deadlock, right? It did run 1, 2, 3, 4, 5. It ran 5 times. So that means it kept on waiting until these 5 times are completed. But still, after the 5 things are completed, we do not have a done anywhere, right? Because all of them are completed. But still, we can see that why wait would go into deadlock? Wait would go into deadlock because even after these 5 things are executed, we have added 10 times. So the counter is at 10. Now, after doing done 5 times, counter goes to 5, right? Counter at this level is at 5. And after this, do you see anything, any done statement? We don't see any done statement after this till wait. That will basically mean that it goes to deadlock. So to fix this, you have to be careful about what number you are adding to the counter. So that's what I wanted to talk about in this topic in wait group. In the next video, we will talk about channels. So I hope you were able to understand wait groups, and I'll see you in the next one.